Momentum is a very important quantity. It combines mass and velocity, and it's conserved. The momentum is conserved in the absence of external forces. And external forces includes things like resistive forces, drag, air resistance, friction, and if this track were not level, there would also be a component of the weight, g sine theta, that would also confuse things. I have taken the time to make sure that this track is as level as I can make it. That's why the two carts sit there. This is procedure 1, two carts sitting in the middle of the track with a spring, compressed spring between them. And I'm going to release them right after I show you the capstone file. And here's the capstone file. I've already logged in on the carts, so they'll start recording. I have blue card on one side, red card on the other, but they will show up together. So let me give you an image that you can see both. There we go. So I press record in capstone, and you see it start to record. I reach over and pop the spring, and they move off, and I stop capstone. So what happens now? First of all, let me get back to an image with just capstone. There we go. In this image, is perfect. This is where they're sitting still on the middle of the track, not moving. Velocity 0. I pop the spring, and both carts move off with a given velocity. Since the forces are equal and opposite, due to Newton's third law, they each receive the same amount of force. And then they move off at a constant-ish velocity. It's not constant. We've discussed this for a couple of weeks in a row now, how the resistive losses in the cart will affect this. Here you see that one velocity is positive and one is negative, and that's correct because momentum is a vector quantity. If they each move off in separate directions, then that's the way you're going to see it. How do you get your data here? Well, what I want to do is if I click on the blue icon here, this becomes darker. That means I can get it, so I can go up here, I can get a highlighter, and I'm not going to take this point here because that's still where it's accelerating, but I'm going to take the next 5 points. Might be 6 there. The next 5 points. And I'm going to use that on both carts as the constant velocity that the cart now has. This way we avoid, for the most part, the change in momentum due to the resistive forces, the external resistive forces. You use this and the sigma button, and you get a mean. In this case, it's 0.579. These carts are fairly precise, and you can count on an uncertainty of plus or minus 0.005 meters per second. You'll do this for both carts, and we're good to go. I'm going to show you the capstone file that you'll be downloading next. I'll be right back. And here we are. This is the capstone file that you'll be downloading from Blackboard to go with this lab. This is an image of the equipment used. The track, I used a scale, which you'll see in a second how I got those measurements. This is the extra mass that is used for the trials in each case, the carts, etc. On the second page, you'll get the masses. So what we've done is I have 3 procedures, one for each type of, different type of collision. And in each of those procedures, I have 2 trials. One is with the carts having the same mass, and the other one is the carts having different mass. And you can see here that I always chose the blue cart as the one with the additional mass. You can also, from this image, tell what the uncertainty of the scale is, and that's important. Here's your data. So in the original one I did, you saw one go positive, one go negative. When I recorded this, I had the carts facing the other way, so both are positive. However, you have to assign a direction to the track as a positive direction. Most sensibly, to the right is the positive direction, and assign the cart that's moving in that direction a positive velocity, and the cart that's moving the other one, you have to make it negative, because as I said, momentum is a vector quantity, and these carts moved off in the first procedure in two different directions. I'm going to show you a second how I did the other procedures, but I can show you the data now. Here's procedure 2. You'll see that when I show you the video, they are sitting there. I give the cart a little kick. It moves off at constant velocity. It then hits the red cart, sticks to it, and they move off as one object. Procedure 3. Here I used the red cart. Both are moving down the track, or sitting there. I kick the red one. It has some velocity. And then the magnetic bumpers interact, and they swap velocities. You'll have to explain what that means. Here you can see that this is clearly higher than this. And was it in procedure 1? Procedure 1, the blue was higher. Procedure 3, the red is higher. So this is going to be due to the loss of energy. In order to get this as close as possible, what you'll do is, the blue one is highlighted here, so the blue one is selected. Select a box, make it smaller if that's convenient, and just grab the first 5 here. Then you'll come over here and select this one, do the same thing, and the nearest 5 here. And that will make your velocities as near constant as is possible with this. When you're doing procedure 3 for the second trial, it gets a little more complicated. There's another step. You'll have to figure that out as you go. It should be obvious by the time you've done it a few times. And that's it. Oh, did I tell you use the mean here? You use the mean here. And that's it for this lab. Everything else is in the Google Doc. Good luck with that. And here's procedure 2. In this scenario, I have set up the carts so that there are pieces of Velcro on either end, and they'll be facing each other. So when they touch, they'll stick. I will put it here. I'll turn on capstone. I'll give it a boost. They stick, move off as one cart. And I'll show you procedure 3 in just a moment. And here we are back with procedure 3. I've mounted magnetic bumpers on both carts. The magnets are set up so that they'll repel each other, and the carts will feel that force. I put it over here, I turn on capstone, I give it a push, and the other cart just pushes it away.